Welcome to another coding tutorial, and in today's video I'm going to show you how to make this kinetic typography made out of a bunch of cubes. This video is part of my Kinetic Typography series. If you would like to suggest an idea, please comment below. We're going to start by learning how to make just one cube. So first, we need to come to this create canvas function, and we need to add in the third argument, WEBGL. And this will allow us to render things in 3D mode. Alright, so I'm going to start by drawing a box, and we can use a function called box, and the argument that I'm going to put in is going to be the argument for the size. So let's put in 50. Two things that I want you to notice. So first, usually when we draw in the 2D mode, the origin is at the top left corner of the canvas, right? But now it is at the middle of the canvas. So this point right here is actually 0, 0. The second thing is that you only see a square, but actually it is a box or a cube. But the reason that you only see a square is because you only see the front facing side of the square. The next thing that I want to do is I want to use the rotate function to show you that it is actually a cube. And we're gonna declare a variable called x, and I'm going to map x to my mouse location between 0 and the width, and we're going to map it to 0 to 360 degrees. So because I'm using the degrees mode in the setup function, I also need to change the angle mode from radians to degrees. Alright, then I'm going to put in x as the argument to the rotate x function. So now as I move through here, you can see that the box is rotated along the x-axis, right? Alright, what if we change to rotate y? So now it's rotating around the y-axis. Alright, how about the z-axis? So this axis is the axis that goes through our screen, right? Alright, and what if we do it all at the same time? So rotate x, rotate y, and rotate z. Alright, so now you can actually see that it is a box and not just a square. Now let's draw another box, but instead of having it at the origin, how about we move it slightly? I'm going to use a translate function, and I'm going to translate it by, how about 50 to the right and 50 down. And then I'm going to draw a box of the same size, 50. So how about we fill the first box red and then the second box white. Alright, so as you might have guessed, the box is now moved 50 to the right and then 50 down, right? One thing to notice, you can see that it is a box. You can see the second and the third sides of the box, whereas if you were to draw it at the origin, you cannot see that. What if we do the same thing? And I'm going to use another translate function, and I'm going to translate it to the left 50 and then up by 50. Why do we only see 2 boxes now instead of 3? And it is because we forget the 2 main functions when we do transformations, which is push and pop. Push is the function that saves the transformations that you do, while pop restores it back to the original settings. The reason that you only see 2 cubes right now is because we draw this red box, right? And then we draw the first white box, but we moved it 50 to the right and then 50 down from the original point, and so we have this box here. But because we didn't use the push or the pop function, we translate it again on top of this first translation. We say move to the left by 50 pixels and then move it up by 50 pixels. So it moved from this settings here to the left and then up, and then we draw this other box. And so this third box is actually on top of the red box that we drew initially. But actually what we want to do is that we want to translate this box from the original point. So we want to use the push function here and then the pop function here, such that before we call this translate function, we go back to the original setting, which is the origin is at the center of the canvas. So if we click run, now we have this third box here. And the reason that now these two boxes are both red, it's because I put this fill inside the push, so it restores it back, and now the third box is using the fill function of the first box. So if I were to put this here, we get 2 white boxes and then 1 red one, which is this top one. Now we want to draw rows and columns of boxes. So essentially, we're going to be using these set of functions over and over again inside a nested for loop. Let's start by writing the outer for loop. So let I equals to 0, I let's do how about 2, I plus plus, and then for let j equals to 0, j less than 2, j plus plus. So we're going to do 2 by 2 boxes. All right, then I'm going to copy this line of code, put it in here, then I'm going to delete this. And before I move forward, I'm going to declare a new variable called size, and I'm going to set size to 50 so that I can put in size here instead of hard coding the number 50. But we don't want to translate everything by size, right? If we do that, we only have one box because all 4 boxes are at the same location. We want to multiply I times size here and then j times size. So we have 4 boxes, and because we put this red here, we don't see it. Let's put it after. Let's say that we declare rows equals to 2 and columns equals to 2, right? And then we can replace this by columns and rows. Still the same thing. And now we want to change it by, let's do 10 by 10. Now it's off the screen. So what we want to do is that we want to shift everything to the left and up, but by how much? So if you look at it right now, right, there are how many here? 1, 2, 3, 4, 4.5. 1, 2, 3, 4, 4.5. So we actually want a total of 10. So we're going to shift it by how about 5? So 5 boxes times the size. So let's try that. So if we subtract it by size times the number of columns, and then subtract by size times the number of rows. Oh, it has to be, because columns is now 10 by 10, right? So we actually want just 5. So divide by 2 here, divided by 2 here. Our canvas is a little bit too small for the size that we set. So what if we do 600 by 600? All right, so you can see that it's a little bit off-centered. So actually, to have the same margin for everything, we want to add size divided by 2 here as an offset. Okay, so now we're smacked in the center. I'm gonna change it back to 400, but I'm going to change the size here. How about 6 by 6? And if you want it to fit the size of the canvas perfectly, instead of giving it the number of rows and columns here, we can also just calculate the number of rows and columns in the setup based on the width and the height, right? So we could do columns equals to width divided by size, and rows equals to height divided by size. Perfect. Next, we're going to create a box class, and inside the box class, we're going to be drawing each of the boxes based on the code that we just wrote. So let's come here, and then we're going to click the plus sign, and then click create file. I'm going to name my file box.js, and before we start writing a class, let's go to index.html file and come down to this line, copy. And then we're going to change the name from sketch to whatever the name of the new JavaScript file that we created. So in my case, it's box.js, and this is a way for us to integrate this file into our program. Now let's go back to box.js. We're going to start writing a class. So start with the word class, and we're going to name the class box. Inside the constructor function, we're going to give it 2 parameters, x and y. Then I'm going to set this x equals to x, and then this y equals to y. And then we're going to write a method called display. And display is going to have functions that we just wrote. Let's go back to sketch.js. They're going to be these ones here. All right, so we're filling the box to be color white, and then we have the push function, the pop function here. Then inside we want to translate it by a certain amount, but instead of having these numbers here, because this is part of the nested for loop, we're going to put this dot x and this dot y. Now let's try to just create one box. So let b, and then inside the setup function, b is a new box. And let's start by putting it in the middle of the canvas. So it's not going to be width divided by 2 or height divided by 2, right? Because now our origin is at the middle of the canvas. So we're providing 0, 0 as the arguments. And then let's comment all of this out. We're going to call the display method. All right, but we don't want to just create one box. We want to create a bunch of boxes, right? And we're going to use a nested for loop here. So for let I equals to 0, I less than the number of columns, I plus plus, and then for let j equals to 0, j less than rows, j plus plus. Now we're going to populate this box array. We're going to make it into a 2D array. So inside the outer array, we need to populate it with empty 1D arrays. And then inside this inner loop, we're going to create new box objects, right? Inside this box here, we need to put in 2 arguments, right? Which are the x and y location of the center of the box. And as we have already done it, it's going to be at these location, right? So we just fill these in here. And then now inside here, we also don't need any of this anymore because we already wrote the method display. Ta-da! All right, so now we have a bunch of boxes. We can delete this too. Next, I actually want to tweak the display method a little bit. So I'm going to tweak the display function a little bit by putting in a different argument here. So instead of just putting size, I'm going to do size minus 1/3 of size to give a little bit of a space between each of the boxes. And then I want to put in 2 more arguments. Actually, we can do 3, up to you, but let's just do 2, which is the rotate function, right? I'm going to do rotate x and rotate y. How about that? Let's just declare the variable x again and have it mapped to the mouse location. Then I'm going to put it in here. All right, so now we have a function that rotates each of the boxes. But just be careful. So the order of the transformation functions really matter. So if you were to put these 2 functions before translate, it does a completely different thing, right? Now we need to figure out how to draw the H letter that you saw that was moving up and down. We're going to use a function called textToPoints to get the outline of the text that we want, or the letter H. To do that, we need to first come here, and I'm going to create a new folder. I'm going to call it fonts. And then you're going to click this arrow here, and you're going to click upload file. And this is where you're going to drag and drop your font file in here. Once your file is uploaded, then you want to use a function called preload. And this function will allow you to preload the fonts into your program. And you also need to create a new variable called font, and we're going to set this font to another function called load font. And then inside this parentheses, this is where you're going to tell your program where your font file is. And in my case, it's in the folder called fonts, and my file is called roboto-bold.ttf. So that's exactly what I'm going to put in. And you need a quotation mark here. Then you're going to put in fonts /roboto-bold.ttf. All right, and then you want to click play just to make sure that there's no error. For mine, there's none. Now we're going to use a function called textToPoints to get an array of points that outline the text that we want. So let's declare a few variables. The first one is, how about MSG for message, and I'm going to set that to the letter H. Then I'm going to create an array called points, and this is where I'm going to keep the array of points that is returned from the textToPoints function. And then 3 more that I want to declare. One is font X, font Y, and then font size. And these are, I'm going to set this to 400. And these are the X and Y location of the bounding box of the text, and it's the bottom left corner of that bounding box, and then font size is the size of the font. So let's set this to 0 and 0 first, and then we can adjust accordingly. All right, and then we're going to set points to the textToPoints function, but we need to put in font, which is this variable here, dot, and then textToPoints. And then inside the textToPoints function, you are required to put in 3 arguments. So the text that you want, the array of points, and then the X and Y coordinates of the bottom left corner of the bounding box. So we have it as font X and font Y. And the 4th and the 5th are optional, but we're going to put in the 4th, which is the font size. Okay, now if you click play, nothing happens because we haven't used any data within the points array yet. So how about we come to the draw function here, and then let's use a for loop to go through the points array. And I want to draw an ellipse on all of the points that makes up the letter H. So points of I dot X and points of I dot Y, and then let's set it to the size of 10, and how about we fill it the color red. Okay, actually let's stop it from moving for now. Okay, go back to Sketch. Because we put font X and font Y at 0,0. That's why the letter's at the top right corner, right? So we want to move it. How about we move it a little bit to the left? Let's do, how about 120? That looks pretty good. Maybe 130, negative 130. And then let's move it down. So down for the y-axis is positive, right? So how about 100? A little bit more. Maybe a little bit more. That looks pretty good. But we don't actually want to draw out all the points here, right? We don't want these red ellipses. What we want is that we want our cubes to have the shape of the letter H. All we need to do is that we need to find the distance between each of the cubes, each of the location X and Y of the cubes, to the points that are along this shape here. And if it is at a specific distance, then we say that, hey, that is part of the H outline. So what we're gonna do is we're gonna come here. I'm going to comment all of this out. Inside this nested for loop, we actually need one more loop. So we're gonna go through, actually it's gonna be k now. And this k is going to go through from k equals to 0 to k equals to points.length. So the length of the points array. And I'm going to declare a new variable called distance here. And distance is going to be a calculation between the distance of the, the points, right? Points of k dot x and points of k dot y, and the boxes, right? Boxes x and boxes y. And this function here called dist, D-I-S-T, is a built-in function within p5.js that calculates the distance between 2 points, and it takes in a total of 4 arguments. So 2 xy coordinates, which we have given here. Then we want to say if this distance is less than, let's do 10, then we want to set boxes of I and j dot is letter, which we have not created in the class yet. So we're gonna do that next, to true. So if the distance between the outline and the box is less than a specific amount, in this case 10, then we're going to say that it is a letter, it's part of the letter. And else, then boxes of I and j is letter is going to be false. All right, so now we're going to go back to box.js and we're going to create a new, actually we don't need this. We just say this dot is letter and we're going to start it as false, right? And then in display, now let's click play to make sure there's no errors. There's none. All right, so in display, what we're going to do is that we're going to write a conditional statement that says if this dot is letter is true, then let's fill it with the color. How about blue? And else, then fill it as white. And something is wrong. What I did wrong is that I put in this additional conditional statement. So I guess it's because there are some points that we go through within this second inner loop, right? That there's a point where the distance will not be less than 10. So it just reset the boxes of I and j dot is letter to false. So we don't want that. So if there's only just one point that has the distance of less than 10 already, then set it to true. So if we do this, then we got something here. All right, so I'm going to actually uncomment this out. So you can see an outline of this H letter. You can see that actually only some of the boxes are blue, right? But we now can play around with this number here to get the outline that we want. So it seems like from here to this point here, it just doesn't match it enough that like these boxes will turn blue. So you also want to play around with maybe this number here too. All right, so now it has the letter H that I want. So now I'm going to comment this out. Actually, I can just, comment it out. Now let's go back to box.js. We were able to move the boxes using the rotate function already. So we don't actually want to map the X location here, right? But we want a new variable and let's call it angle and set it equals to 0 as the initial value. And inside here, let's use that as the argument, right? And then, so now what if we just rotate the boxes that are part of the letter H? So we just do this dot angle plus equals to 1. All right, and then we can do the same thing to the rest of the boxes, but what if we rotate to in a different direction? That looks pretty cool. All right, the last piece I want to show you is the depth. So let's declare a new variable called depth, and then I'm going to set it to 0. This translate function, we only translate it in the X and Y direction. Right now, if I were to give it the third argument, which is the Z direction, so if I put it at 0, right, nothing happens. But what if I set the variable Z and map it to 0 to, actually, mouse X, 0 to width, and then 0 to 100. Then I'm actually going to comment this out for now. Let's look at this. Oh, I need to set this here. Do you see that? It's moving in and out, right? So I'm going to use this third argument here in the translate function to move the letter H, to move the cubes that are part of the letter H up and down. We don't need this. I'm going to uncomment these two. And I'm going to use this Z, this third argument, and I'm going to put this dot depth. And I'm going to say that if it is part of the letter, then this dot depth is going to be equal to what? I actually want it to move up and down in an oscillating motion. To get the oscillating motion, I need to use a simple harmonic motion equation, which essentially is the sine or the cosine function. So I'm going to set this dot depth to be equals to this dot depth plus, let's do, how about sine of, and then I'm going to just set it to this dot angle because this angle is already incrementing by 1. And instead of doing this dot def equal to this dot def plus something, I can just do plus equals, right? Same thing as this. We don't need this plus here. And let's try this. Do you see that? It's moving up and then it's going down. But because the output of the sine function or the cosine function ranges between just -1 to 1, and that's why you can see that this oscillating motion is, you can't really see it that much, so we can change the amplitude to get a bigger motion. So how about we multiplied it by 5? All right, so that is a lot. So you can play around with this variable as well. To get the image that I had initially, I need to change some of the appearance a little bit. So here, I'm going to change the stroke to white and with a transparency of 100. But if, and then we want it to be no fill. And then if it is part of a letter, then the color will be white. And we also want the sketch file here. And then inside the background, we want that bluish color. So 0,0,139. Let's try this. All right. This is a great tutorial that combines a lot of different concepts, including how to draw things in 3D, how to use the textToPoints function to get an outline of the text, how to map that into the shapes that you want, and how to use the sine or the cosine function to get the oscillating motion. So I hope that this sparks a lot of your ideas. If you have a suggestion for my next tutorial, be sure to comment down below. Give this one a try.